In this work, we explored success criteria and barriers in first-year undergraduate science labs. Cognitive overload can occur in labs due to students simultaneously needing to understand new theoretical concepts and learn new practical tasks, and this can reduce the opportunity for learning. Pre-lab options can increase preparedness and reduce cognitive overload. An increase in perceived preparedness can be described as the students feeling more able to achieve their success criteria and seeing less barriers to those success criteria. So we can assess the efficacy of pre-lab options by exploring success criteria and barriers. We developed a survey for the students with 3 sections, and only one of those sections is in this project. That section had 2 open questions. How are you defining success for this experiment? And what are the barriers to you achieving success? The other 2 sections are the preparation that the students did and 14 different aspects of preparedness. The survey was administered to first-year undergraduates in physics, chemistry, and chemical engineering. It was administered in the week of their first experiment and then 7 weeks after. Paper copies were handed out by the teaching assistants as the students arrived, and they were collected in before any teaching or experimental work was started. So the students' responses weren't influenced by how well the experiment did or didn't go. 30 randomly selected surveys were analysed for survey 1 and 2 for each subject. The procedure was a familiarisation stage where all the survey responses were read. Then coding of keywords and phrases, formation of themes from those codes, and then documentation of the codes and themes, and this also served as a good review stage. The theme occurrences were then analysed. So is the sample representative of the full data set? This is the percentage completed as a proportion of the total in lab, and this is the percentage analysed. We can also look at data saturation. So have we identified all the themes? So we looked at the survey number at which the last 3 themes occurred. For 9 out of the 12 analyses, the last theme occurred within the first 3 quarters. So it's likely that we've identified all the themes. For the 3 analyses in orange, the last theme occurred within the last quarter. So it may be there are further themes to emerge in these cases. I've presented the result as an infographic using all themes, and also given examples of the top 2 success and barrier themes. Statistical testing for differences between survey 1 and survey 2 was done using Wilson's method. So here are the results for physics, but I'll talk through the infographic first. Survey 1 is above the dashed line, survey 2 below. There are 3 time segments: before, during, and after the experiment, so there's a timeline. Font size represents the percentage of students. The dashed line represents 0%. Small is less than 25. Medium is greater than 25. And large is greater than 50%. Barriers are in red. And success criteria are in green. So some general trends for all 3 subjects. Barriers tend to occur before and during the experiment, and success criteria during and after. Success tends to have 1 or 2 dominating themes, as you can see here, and barriers tend to have a broader spread. So in physics, gaining experimental results and completing the experiment are the top success criteria. Being able to use the equipment and time are the 2 top barriers. So this gives us an insight into how the students are feeling just as they're about to start the experiment. They want to get some experimental results, they want to complete the experiment, but they're worried about being able to use the equipment and they're worried about getting it done in time. For chemistry, the top two success criteria are gaining good technique and experimental results. For survey 2, it's results and completing. So technique is about in-lab mastery. And this is the only time we see that in-lab experience being a success criteria. And for chemistry students, there are less students that are interested in this in survey 2, and the emphasis moves towards results, and these are significant changes. The top two barriers are adequate technique and time. Safety doesn't have a particularly high percentage, even though it has a very high profile in chemistry labs due to the COSH forms and the protective equipment. The top two success criteria for CS are experimental results and completing in survey 1, and results and assessment in survey 2. So this is the only time we see academic marks being a priority to students as they start the experiment. And it may be that we see a high percentage of students stating experimental results and completing as success criteria as they correlate these with getting a good mark. The top two barriers are prior knowledge and practical skills in survey 1, and practical skills and error analysis in survey 2. So the lab course isn't aligned with a theoretical lecture course. So the knowledge that the student has comes from their own learning or pre-lab material. Less students are concerned about prior knowledge in survey 2, indicating they're gaining more confidence. Error analysis occurs as a barrier in the second survey, and that could be because the students are realizing the complexity of this task. These are the top two success themes for physics, chemistry, and CS. Gaining quality results appears in all three, so getting a precise and accurate value for the constant, as does completing the experiment, finishing it on time. Getting a good mark is only there in CS for survey 2. The top two barriers for physics, chemistry, and CS. Again, not understanding how to use equipment or something similar is there for all three. And time limits is there for physics and chemistry, but not for CS. So to conclude, gaining good quality experimental results and completing the experiment are the most often stated success criteria. Barriers have a broader profile. Practical technique or something similar is the most often stated. And students tend to be focused on experimental outcomes rather than in-lab mastery or academic marks. Applications. So the infographics can be used to give us an understanding and insight into the students' experience of labs and their priorities. And we can assess the efficacy of pre-lab options. So are we addressing all the students' concerns to help them feel prepared? We can compare student priorities against stated learning outcomes and also staff assumptions. For example, there's anecdotal evidence that staff think students are focused on academic marks, but this research suggests otherwise. We can use the infographics as training material for teaching assistants. They can see the students' view of labs and they can see where they can support best. They can also be used as support material for students. So any concerns they have, they can see that they are shared and this is a common experience. And we can also indicate where the wider learning outcomes are. For example, students are learning to work under time pressure. They're also learning to pick up new techniques quickly. So thank you to all the staff in labs that supported this. And thank you for your interest and for listening.